Use the rational zeros theorem to write a list of potential zeros. All right, so now for this one, you just got to take the leading term and the last term and then write all the possible combinations and fractions. Okay, so you've got 2, which is really just 2 and 1. And then you've got 8, right? Which is the answer B? No, it's D, right? Okay, I wanted to double check that because I sometimes forget. Now the prime factorization of 8, well, you got to write out all the factors. So it's like 1 and 2, and I'm writing this wrong. So the factors of this is 2 and 1. This one's 1. I'm writing it like a factor tree, and technically it's not. It's 1, 2, 4, and 8. And so the combinations of this is going to be the last term divided by the leading term, the factors. Okay? So you would get like 1 over 1 if I were to change this from 1 comma 2. So I'm going to do 1 comma 1, 2 comma 1, 4 over 1 comma 8 over 1. So that's like doing the ones with all of these. Then I'm going to do 2. So then I'm going to, and it's plus or minus for each one of these. And then I'm going to do 1 over 2, right? So I'm going to do this on the bottom, and these are the numerators. So it's like 1, 2, 4, and 8 all over 2. And then it's all plus or minus for all these. Okay, now these all, 2 over 2 is like 1, 4 over 2 is like 2, and then 8 over 2 is like 4. So we don't need to list those twice. Does that make sense? And that's where it comes from. So when you go to do synthetic division, you literally have to try all these numbers, and one of them will work if there's a real number solution in the polynomial. Does that make sense?